glad you guys all made it. This will be our biggest class yet, so hopefully we'll get through a lot. Today we're going to spend time on reading wiring diagrams and control prints and try to help make some sense of things. And several have not had exposure to this. Some of you are very familiar with it, so we'll try to keep moving as quick as we can, but keep everybody with us. We're going to start by looking at the control panel diagram that is the 11 by 17 sheet that looks like that. Does everybody have one? What we want to do is we've spent some time working with relays, and so this particular drawing has a number of different ways that relays work together, and so we want to just see if we can analyze, figure out the function of what the relays and the contacts are doing. If we first start in the upper left corner of our drawing, that's kind of what I've got zoomed in here, we do have a power supply right here on the upper left. So what kind of voltage are we dealing with inside of our panel? The panel is the lines of the box, kind of everything inside of it are in, things outside are in the field. So again,
120 and 24.
Okay, so I heard 110 and 24, but I don't know what that means. 110, okay.
20 coming in, going to transformer,
24 volts DC or AC?
AC.
Okay. All right. So we're 24 AC, and that's our R and C typically are how we label. 24 high is R, 24 low is common or C. Okay. Can you get another set of things? Okay, so we have R and C. So very first thing that we're going to look at is this little piece right here. So we have a couple things right here. F/A stands for fire alarm. Okay, so who can tell me what this is doing?
Locking the fan out. Yeah.
Okay, so fire alarm is supposed to just, basically lock the fan out if there's a fire alarm. All right, will it work?
Not the way it's drawn.
It's a good drawing, perfect drawing. Okay, and I know a few of you that are very familiar with relays see it. Does anybody else see why won't this work?
There's no power going to the contact, the relays.
Okay, so there's no power. If you follow this, so say I start at this C, I come out, there's a dot right there, I go up through the contact, come down, there's a dot there, I come back around. There's nothing powering that circuit, it's just a circle. So as wired, nothing will happen, right?
As drawn.
Yeah, as drawn, and hopefully it's not wired that way, but if it is, it's not going to work. Okay, so there's two ways that we can fix this. All right, one is if the fire alarm system is 24 volts DC, and I can get to that 24 volts DC. So say up here, somewhere out here, I have 24 volts DC available. What would I have to do to fix this? Would you kick up our screen all the way? And I apologize, this will be a little shiny for some of you. So how can I fix that? Anybody? Okay, so say I've got 24 volts DC plus and minus right there. Matt, go ahead, give us a shot.
I'm going to assume we still want that contact in there, so go to the left side of the contact and separate the wire from the contact and go up.
So we'll get rid of that wire right there. How's that?
And then go off to the right side of that coil that's right next to it. Or
Probably should have got rid of the other side of that contact.
Either way works. It's just,
Yeah.
We're just putting, what we're doing is we're putting the power in series without contact.
yeah. So we basically bring power into there. I'm going to just draw this out. It's coming down. There's a break in the line right there. We come down there and we go up, and we're going to say that this is wired correctly on the coils. We're not going to worry about which, if it's DC, the coil may be polarity sensitive, but we'll say that part gets wired right.
Now you bring on both.
Okay. I'm going to switch to blue to make it easier. So now I need to be C on this side, right?
Bring that back to the common source of the 24 volt.
So this is coming up, and then somehow, and I'm going to just do a dotted line to get over here so we can get to the minus. Okay? So that's how we fix that using the existing equipment. I've got a DC relay because it's saying that's what it is. So I didn't have to change any equipment. Say, for instance, I decide, I don't want to use the DC because the fire alarm system won't let me borrow their power. How would I fix that? Using our panel power.
Full bridge rectifier in there and bring it in. Change out the relays.
Okay, so we could change these relays, maybe instead of a rectifier. You could do 24 in here, but we don't have it. So using what we have, maybe easier would be.
Change out the relays to a 24 volt AC.
Okay, so these become 24 VAC.
And then wire it off of your transformer.
Wire, yeah.
Okay.
Similar wiring scheme.
So we've got something really similar here, right? We're R and C, so we take an R, and maybe we go up here and over to there with R. What do we do with this?
Cut and put C there.
So that needs to go away. And then we actually should go R through the contact first, right? So let me fix that. Why do we usually want to run our high side through the contact first?
So there's not power at the relay all the time.
Yeah, it's a best practices kind of thing. Can you switch the common side? It happens.
To run a risk of one side of the transformer being grounded,
Okay,
and then if your wire gets grounded, it turns things on.
it does. And so you can get some things happen that you don't want. So that's why we try to always switch the high side. So instead of what I originally drew, we're going to bring this down to our R, up through there. Okay. And then these are broke. Sorry, not broke, but they're just jumpers. They're not tied. These are really new markers. And so that's tied there. Okay, does that make sense? So now we fix that problem. So just remember, you've got to have a power source, switches or contacts or something, the load, and then we go to C. And then that's how you wire that up. Okay.
And that would have to be something fed from the fire alarm system, or if it was just powered off the unit, it would never shut the fans off.
Right. So in this case, the way it's drawn now, we've powered it out of our panel. And so this would work because this dry contact is into the units, and that will work because they've got some power feeding in and out of our contact.
But the fire alarm panel or coil is coming from
So-
the fire alarm.
Yeah, so you would have something,
Fire alarm relay switch.
a coil here, which would be 24 volts DC. That would be your fire alarm. And it would be something like that. So that would energize, we'd use the contacts from there, and then it would work. Okay, so we fixed that problem. What's going on right next door? This piece here.
Short there.
It's Giving us
Okay.
a status of
Hawkeye.
the fan running or not.
Okay, so we're using a Hawkeye, which is a current switch, or in this case, it's a current transformer. It's a current switch in this case. It tells us that here. So that acts just like a relay contact, right? So you got a contact here that somehow, if current goes through that wire and we're monitoring it, that will turn on and off or switch that contact to the closed position. If this closes, what happens here?
Energizes that coil.
So-
Green light.
That relay coil gets energized. Green light turns on maybe in the panel front, something like that, so we have some status. Okay. How do we know what this affects? When that relay turns on, where does it go? What does it affect? What does it change?
CR2.
Okay, so the CR2 here corresponds with that. The -1 tells us what?
One contact.
First of the contacts, first set of the contacts. Now, this doesn't have the little 2P, 3P, 4P up next to it like some do. Not all do, but that tells us how many poles or how many sets of contacts, right? In this case, we assume it's at least one. It's probably two because that's a lot of times the ones that we use. But one of those goes here. And what is this telling us? What is this doing here?
It's input to the card, provide a status on DVC.
Okay, so we have our controller, our card that's collecting information. Because it's a closed contact, it's a status into the controller. So these little resistors that you see underneath, or on the inside, those are in and wired at the base. So if I pulled the card off of the base, you would see a resistor put in between those terminals. And it's used to work with that particular contact to make it work for the controller. Okay. So this gives us the status then of the kitchen exhaust fan number 11, and then kitchen exhaust fan number 10 is down a little bit further. If we just scroll just a little bit, you'll see there's number from this one here doing the same thing. Okay. All right.
There's a legend in the top right that identifies it as a 2-pole.
So a parts list here that we have gives us some more detail if you're not sure what things are. You know, AC relay base, types of poles, stuff like that, flow switch. So that's kind of handy. All right, let's dive into this piece real quick. So here is an example of what we normally don't do. What 25 is not on your drawing. It's on this maybe page 2 or something. But what is the effect of CR25 on this part of the circuit? So this is the kitchen exhaust fan, number 10. So what is this relay going to do?
Let's energize it.
So if it opens, what does that do to the fan?
Shuts it down.
Okay, so more than likely this is what? Interlock safety, something like that, right? We don't see it on this page. We'd have to go to page 2. But if that opens, it's going to basically close or remove the flow of electricity through that coil. How should we have probably wired this so that it was more correct or better practices?
You don't want to fail things on, well, I guess some things need to fail on, but this probably needs to fail off.
That
Rather
really,
than on.
that really CR25 is in a normal closed position, right? So it's always providing power to that exhaust.
Yeah, so it's gonna take power to disable it, and I think that's okay. Let's assume that the functionality of the contact is correct. As far as where this contact is, where might be a better place to have put that instead of in the common side?
On the R side of the tower.
Okay, so if we were to take this and just to put it right there, then our handoff auto switch, our automatic enable switch, our safety interlock is all on the switched leg going out to that relay. If I get a short anywhere with this, it doesn't matter, it may work even though that opens, right? And so So that's one thing that as you look at a print or we try to avoid switching the common side. Okay. We're going to scoot to the left now and take a look at this one right here. And let me see if I can get all of this on here.
I think the handoff auto switch is drawn wrong as well.
Ah, wonderful.
Yes.
We're going to talk about that handoff auto switch. Make sure we get all this in here. So, in the previous class, we've played with this and we figured out that yes, indeed, this is labeled correctly, but drawn is incorrect, right? Usually when you see two sets of handoff auto switches, if I switch up, I go to both up, I go to both down, and that's a standard way of showing a switch. In this case, the autos work together, the hands work together, which is confusing. Okay? No.
It is.
Did you switch this? Or did you add
I
this?
discovered that it was labeled wrong and drawn wrong,
Ah.
we changed the labels.
Okay. So the fact that this came out in the last class and then Fernando caught it, this is a good thing. So
Auto is right, hand is right, but this should be aligned and they're not.
say for instance we were going to put this in auto and I go here. If this was normally the way that we represent it, then I would be here. So I've got 24 volts going to CR24 energizes, and then I've got hand. Well, hand comes up here and I can go to heat, it turns on the heat. I go to cool, it turns on the cool. Or I can go to higher and low speed off of this switch. But I have no way to control it using the auto function from the controller. However, if this follows that way, so auto and auto, then my auto circuits come into play. All right, so this is how that switch is actually functioning. We just need to flip it on the drawing. Okay, so say we're right now in the auto position. What's going on with CR24?
It's energized.
Okay, and how many contacts does it energize or are part of CR24? Okay, so we're going all the way through here, right? 24, 1, 2, 3, and 4. All right, so this piece of the circuit has to do with our auto. And if we follow these relays, they're all up right in here, except 19 and 20 are on another page. Okay, if we were to go to the first one, we would see 21, 22 on that. I think the left exhaust fan 10, or makeup air unit 1. So let's say that this is 19 and 20 here instead of 21, 21. What happens when I energize CR19 and I'm in auto?
Heat comes on.
So this guy is made all the way through here because we're in auto, right? 19 gets energized. We turn, R comes up, goes through, and then drops back down. Same for cooling. If I do cooling with 20. What about 11 and 12? It's your low and high speeds, right? And again, those are controlled through the automation system or in automatic. If I were to switch things to hand, those open back up. Hand doesn't do anything here, right? It goes to dead, but this then takes my R from the unit, so it's R's coming from the unit, goes up to the switch, and so if I say heat here, and it just comes straight back down, and I've got heat on there. Or if I go here, I go low speed right out there. Okay. So by using this double pull, double throw kind of handoff auto selector, we get both functions and they're switched that way.
I think you gave me too much credit. I hadn't even looked at this one. I was looking at that handoff auto.
Oh, okay. Well, you still got this one. We'll give it to you.
Okay.
So let's look at this one then, real quick. Okay, So in auto, R goes over, comes out, energizes, disabled by the safety. In on, you'd have a relay.
It's interrupted.
So that's more of our auto thing, right?
Yeah.
So this should be our on, and this should be our auto. Good catch. I didn't see that one before.
And see, if you look at it from that perspective, you go back to CR 25-1, where it's on the comment. If you put that over here on R, you power R through that, you're bypassing that entire switch right there, right? So you'd be bypassing your handoff on.
Yeah.
So you gotta keep it on the common, otherwise you're not, otherwise you're gonna bypass that. So,
You can put it on 40.
You just put it right here.
It's still bypass.
yeah.
You put it right
But you
there.
got power going to that contactor. So if you got an R coming to that contactor and that energizes, you're gonna bypass that HOA switch.
So you won't hear.
The R's coming the other way.
Or, and then you gotta go through that.
Yeah, R's going through HOA, right?
R comes either here, down and out.
Never mind, you're good.
It's all right. That's why we do this, because sometimes things look one way until we talk about them. Okay. They must have had some other things with these here that we don't know about. Maybe there was some piece that tied right here that had to do with a hand or just, some sort of an auto function. We don't know. Maybe it was a damper, something like that, but it was removed. Okay. All right. Great. I think we've caught all the things and solved all the problems. Any questions on this diagram on anything that we didn't look at? We didn't look at this little scaling or signal output thing, but we're not going to worry about that right now. Okay. Any other questions though on this?
It's nice that they actually have a sequence of operation listed right on there.
That is handy.
A lot of times you spend hours trying to figure out what it's supposed to be
Okay.
doing.
Sometimes they're not right, but
Yeah.
hopefully we get some updated information that helps. Okay. All right, let's switch over to our other piece, which is going to be the carrier. So I found this carrier wiring diagram a number of years ago, and I thought it was a pretty medium kind of representation of a wiring diagram you might find out in the field. It's not as hard as some, but it does have a little bit of, hard to read maybe at first. And so I think it's a good one that we work on, look through to try to troubleshoot and figure out how do we wire this, how do we put a meter on it, check things, and come to understand what's going on. So if you're not familiar with how a chiller operation works, this has, much like we just mentioned, an operating sequence. I'm not sure how detailed this is, but it gives you at least some indication of how it should work through, there's some unit stoppage and low pressure switch stuff. So there's some information there to help you know how it runs. The second page at the top has a legend. Do you want to go ahead and drop that screen back down? So this legend gives us some indication of usually the acronyms that are used out on the drawing. So some of these you may be familiar with, others you may not, but this is a good reference. We learn about the different types of terminal blocks, the different ways that they're drawn, what they mean. Also, factory wiring is a solid wire. Field wiring is a dashed line. Sometimes that's hard to tell, especially if you don't have a lot of room. Dashes don't always look dashed, so be careful. That's kind of something that could catch you. And there's some notes. So note 8 has to do with page 5. And let me get back to 5 and just show you. I'm not going to twist my view, but it's this controller piece right here. So if we go back to 8, note, it says, the internal parts shown in the control module are not physically located in this module. The module is solid state, but the relays have been included in the schematic to provide a clear understanding of the control module logic. Okay, so everything in that box is integrated. It's just shown so we kind of understand what's going on, the logic of it. Okay, so these notes can be helpful as you look through the wiring diagram to determine what you need to do to implement things, to troubleshoot things that are interesting. We now have a layout on page, is it 3? Page 3 gives us a physical layout of the compartment. So when I open the door, this is how the pieces and parts should look as they're mounted inside of that opening. Okay, I have a circuit breaker up here, some fuses, this FC123 for fan contactors, C1, C1A for our compressor contactors. I have some terminal blocks down here, a switch that powers CB2 and a switch there. So a TDR, what does TDR stand for? Time delay relay, or what was it? Temperature? Temperature tantrum? No. So it kind of helps you have a layout of the system. Page 4, we now get into what looks to be our high voltage side of our unit. You can see I have 3 phases that feed into what looks to be a compressor, and how many stages or sections of that compressor are shown wired here? 2 stages, right? I got a upper section and a lower that show 3-phase wiring to it. So there are some options over to the right that could be wired in depending on the model. So if it's a single stage or single section or different types of wiring. Okay. I have here some fan motors, FM, and how they're wired up, and they have FC1, FC2, FC3 for the contacts that turn those on and off. Okay. There's a motor master controller wiring, if you're using one of those, that shows how to tie that into our FM1. Down below here, again, this is all the higher voltage stuff. I have some switches. This type of a switch is a temperature-based switch, okay? With that little squiggle line, if I can find the button. So this little squiggle is kind of a temperature-based. This here is some sort of a heater, right? So it's just showing a place where we're going to pass, it's a resistive load. We're passing electricity through it. It's going to heat up. What is this kind of a switch? Pressure. So pressure, that's a symbol for pressure. We have this little guy that's more of an electronic switch of some type, okay? And in this case, that's the time delay relay. What is this symbol?
Liquid line solenoid valve.
Okay, so it's a solenoid. In this case, this is the liquid line solenoid that opens and closes to allow the refrigeration process to work. So solenoids are drawn like this, at least in this schematic. I've seen them as a circle. But each drawing will kind of standardize throughout the drawing, and hopefully they don't switch from page to page. What are these here?
Coils.
So those are coils for relays or contactors, right? So contactor or starter is just a big relay. And in this case, we've got some contacts here. We have some more for, these are the fan motors. This is your compressors. Okay. What is this where I see GRA, BLK, BLU? Wire color, right? So it helps us to determine wire color for tracing things out. Okay. What about this guy right here?
Transformer count depending on voltage.
Okay, so we have a transformer. Anytime you see these squiggle lines with the solid bar or double bars, that's indicating I'm using a transformer. It's a symbol for transformer. We have 230 volt tap, a 115 tap, a 208 volt tap. So depending on the type of system I'm hooking up, I'm going to use one of those voltages, okay? And we have a switch here, just a common switch, another switch there. If I come down just a little further, I guess I'm going to have to shrink this a little. you can see here I have some squiggles that look just like the ones up here.
Secondary.
So this is tied to that. So this is giving me my low voltage side. And what are we here?
24.
24 AC, right? Could this be DC?
There's
Well,
rectifiers in there.
different transformers.
Transformers don't work with DC.
Yeah, so transformers are made for AC. If we were to have DC here, we would need some other circuitry or a PS, power supply type of thing that maybe doesn't show that circuitry. But if we have just a transformer, it's going to be AC. So as I look now at my second page, we'll see if I can get this all in there. So I have 24 volts. We talked about ladder diagrams. This side of the page is going to be 24 low or high. Why? So I'm this is where all the switching's going on, right? I've also got what's up here.
Your control is a lot by using commons, right?
Some do. Honeywell does too, but let's not get into those.
So.
We know they're backwards. So right here, what is this? So it's like some sort of a circuit breaker thermal overload, so that if anything shorts on as I'm switching it, I pop the fuse, I don't ruin my transformer. So because I have a circuit breaker here, I'm doing all my switching here. This is going to be my 24 volt high side. This will be my 24 volt low side. Okay, as we look at that, the common.
Because it's brown, right?
Okay,
Yeah, 'cause it's brown.
see that thing? It says COM there.
Brown is brown.
Does that mean it's common? I don't know why you'd use COM there because it throws you off, but it's 24 high, right? This is tied into this with the rest of it. So for some reason they've got common there.
It's just a common terminal.
Yeah, and maybe that's all.
Terminal 4 right now.
Yeah, you can see there's a 4 here, 4, 4. There may be another down below. All right, so there's a lot of things going on here, but as we've already talked about, we have switches. Let's see, so we have a switch there, a temperature switch there. We have contacts, a pressure switch, things that we're used to seeing, right? So if you're going to troubleshoot something like this, walking it through, following the line is your best bet to try to find your way through and figure out the problem. Okay. On the handout, we're going to spend some time primarily on this page. So this is the lab piece. It's the one-page sheet that says Carrier Unit Interface Lab. What I'd like you to do is we'll take probably 7 minutes and give you a chance to find the items that are talked about in here and complete the things that need to happen. And then in about 7 minutes, we'll go through these together and make sure everybody gets it. All right, you guys ready to, let's go through this together. All right, so question 1 says, describe where you would wire a chilled water pump status as a safety interlock.
Yep.
Okay, so 2 and 3.
Of the accessory wiring.
Okay, so we're up in this area right here, right? Now, one of the questions we had in a previous class is this here from the factory?
No.
Okay, no. It's hard to tell, but this is a dashed line, right? So this is something that is field installed. It doesn't come from the factory. But there is a note there. What does the note tell us?
Yeah, it even says,
So it can't be purchased.
note 7, it says all field installed.
So the note 7 says field installed. What else does it tell us in note 7?
Use the right wire.
The right wire type has to be able to carry 2 amps, 24 volts.
Remove the
The
jumper.
red one. We use red wire.
And 1, 2, and 2, and 3.
Okay, so what do we need to do?
Remove the jumper.
So there's a jumper as well that comes, what, from the factory or installed in the field?
From the factory.
Okay,
It's already installed.
it comes from the factory.
Taking the place of that.
So that's this wire here, this black wire, and it's the same on 1 and 2. So our first two questions, same kind of thing. If I have the safety interlock, I then remove the jumper wire that was installed at the factory.
And that's where the
Okay.
safety switch goes.
Right. So does that make sense to everybody? Any questions on that? Okay. 3, where would you hook up either a visual or audible alarm?
On 3?
On, yeah, number 3. We skipped 2 because 2 and
It's the same.
2 is right next to it. It's the same exact kind of setup.
The alarm switch.
Yeah, TB, yeah,
TB3
TB3/8.
So right there, right?
There with,
So we have dashed wires, so that means field installed. So if I put either an audible or a visual alarm here, what type of alarm does it need to be? 24 AC, right? Okay, and so it shows that I'm going from TB8. Is this switch included, or am I adding that?
It's field installed.
So probably field installed because there's a little gap on either side of it. Again, they could have stretched this over a little bit to give us a little more dashed line, but my guess is the switch and the alarm are field installed. Okay. All right. How would you monitor this with the building automation system? How could you?
You just go switch coming off that alarm switch, drop down there, put in whatever you need to do, and bring it back to the car.
Status relay.
Well, that'll be a lot
status
of
relay.
Okay.
Yeah, you
So-
can status
24
relays.
volt Hawkeye.
What I could do here, and essentially, is I could come off of, now do I want to come off of here over to a relay coil?
No, you wanna go through it.
You wanna go from off terminal 8.
Yeah.
Probably 8, right?
Yeah.
So, because if somebody opens the switch, the audible can shut off, but I want my building automation to still see it the whole time. So I'd draw a line, come over here, put a relay coil, take this all the way back to terminal 4 on the far left. Okay, or the common, or that's the 24 high, right? We're coming over here. That switch really should be over here, but we didn't draw this, right? This side is switching the common side, okay? Because of this controller controlling the alarm, that's the way they had to do this. So we'll give them a break. This is solid state. This comes back over to our C side, right? So we got a relay, take a pair of normally open, normally closed contacts, whichever you need, and that feeds back into an input or into a panel somehow and into our automation system. Okay. The next one asks, how do I wire in a demand limit switch?
That's the other accessory that's down towards the bottom.
Okay, so down here in the bottom left of our page,
4 and 5.
okay, do I need to remove the jumper? Okay, what does a demand limit switch do? If we look at this circuit, let me back it out a little bit.
Unloads.
Powers the unloader.
Okay, so I'm taking 24 volts. If I close the contact or put a jumper there, it comes straight over and energizes my unloader. So an unloader, you may not know, air conditioning, but an unloader keeps a compressor from running at full capacity, right? It's unloading it. So it's going to,
It'll take pistons out of the, half of the pistons out of the circuit, or
yeah, there,
one whole compressor.
yeah, it could do different things. So it's going to basically lower the amount of energy being used, okay? So that's what a demand limit is like. If I have my demand for electricity is so high that I got to start shedding some of my loads, then I would energize that. So having a solid line here would never let this load up to full capacity. So if we put a demand limit, it's got to be a switched contact, like it shows there. Okay, 5. How would you monitor the unit's control power as a means of ensuring that the unit wasn't tripped? How would we do that?
You're talking about the circuit breaker trip or the logic trip?
So we want to make sure we'll say the secondary side, the low voltage side has power.
bring it
For
to
the
a control where
status,
they
relay,
transformer.
fuses.
Okay, so where do I want it? Here's our transformer up here.
You're just checking power on the secondary side, so you
In
can put a
series.
control relay right there and come off a contact, go back to the cord.
Okay, so I've got a 1, a 2, a 4, and a 7 on this top. Where do I hook one side of, and what am I hooking?
A relay coil, between 4 and 7.
Okay, so I've got a 4 and 7. Anybody else think we could do it differently? Would we want to go 1 and 7?
One's coming off a fuse.
You could do one, yeah. 'cause
Come off
it's
at
on
1 and 7,
it's
so
on the
these
hot side.
are
You
blows.
can go 1 and 2 and have it close on alarm.
Yeah, you want to check and make sure your fuses are
Okay.
good, right, so.
So there's a couple ways we can do this. If I were to tie 1 and 7 to my relay coil, what happens if this fuse or my circuit breaker opens?
You get a feedback back to your system telling you got no power.
You don't. Because 1 is still hot because this is always energized. So if you wanted to keep track of primary power, you could do 1. 2, which might be hard to wire to, would be better maybe to come to 6 or 4. From there, I know if my circuit breaker trips on my secondary. Okay? And so that's probably a better option, tie the other side to 7 on the other side. Okay? And then again, we take a normally open, normally closed contact, whichever we need, back over to our controller. Okay? Now, the other thing that was mentioned is you could put a coil across 1 to 2 right here. What would that tell you?
It would only indicate if the transformer is live and the breaker is true.
Yeah. So you will potentially backfeed through this, and you would have a voltage drop across that if that opens, if you get a trip. I probably wouldn't do that because it'd be a little more confusing, but you could do that there. That would be another option. Okay. And then the last one, what is the purpose of CR1? Where is CR1?
To the right.
So CR1's here. Now, one thing I didn't point out to you, these numbers over here on the side, they indicate what line the corresponding contacts may be found. So BPR, for instance, since we're right here at 35, if I come 35, see here's 35, there's BPR right there, 40, there's another BPR. So if we're looking CR1, it's saying lines 23, 26. So if I come up here to 23, 26, 23, 26 are there. So there's my CR1 contacts. So what are those guys doing? So let's say we're not energized. I have power flowing here. What is that doing?
Crankcase heater, keeping the refrigerant, that liquid refrigerant compressor.
Okay, so you have a CH and there's a CHC. What is CHC? That's coming off a different line, but that's tied to a thermostat, right? CR1 goes there and it hooks, it just energizes that crankcase heater. So if now I energize CR1, what happens? Crankcase heater, what does it do? Turns off.
Energizes.
This CR1 contact closes, and then I energize all of this stuff. Okay, what do I do here?
Just goes through a time delay,
So it says 10 seconds.
and then energizes the liquid on cylinder.
Almost just
Okay.
set up on a pump down basis.
Yeah,
so
say once it's a
pump
pump
down.
down. If it's a pump
concept.
Yeah.
it starts.
So when that shuts, the system pumps down, I get a low pressure, it turns things off, and it just stays there as long as I've got a low pressure. As soon as I open this, the pressures kind of go back into normal operation mode. I'm no longer,
Low pressure.
yeah, the low pressure switch makes,
Then closes your
and
compressor.
okay,
System set up to keep the refrigerant out of the compressor, right? That's the whole concept.
yeah. So we come down here, and now here's my compressors, right? Those are energized. And then I have some stuff here. What does this stuff
Your
do?
fan coils.
Okay.
Or your, well, your
So fan contactors. So 3 different fans. The first fan comes on, or does it?
Immediately.
So the first fan comes on automatically.
It energizes.
The second one comes on and off by a pressure switch. Third one comes on for this model, so some sort of temperature switch, okay?
Ambient temperature.
There you go. So those 3, you know, if you've got this model 035, that one's in there. If not, we're just going off of these 2 here, right? Okay, so we've kind of gone through this. How do you feel about this wiring diagram now compared to when you first saw it? Better?
Sure, yeah. So,
Yeah, you were so much better.
Feeling